So in this problem, we're again asked to write an arithmetic sequence, but we're not given everything that we want. So the things that we are given, notice we are given the 19th term of the sequence, and we are given the common difference. So what I'm going to do is I'm going to plug in what I know. So again, our formula is a to the n equals the first term plus n minus 1 times d. So I'm going to plug everything that I know into this and then solve for what I don't. So let's see. We know the 19th term, right? So we know the 19th term is negative 45. We have no idea what the first term is. Again, n in this case is 19 because it's the 19th term, so I'm going to do 19 minus 1. Oops, and the common difference we were given to be negative 3. So notice from here, this is something I should be able to solve for the first term. So I get negative 45 equals the first term plus 18 times negative 3. So negative 45 equals the first term minus 54. So it looks like the first term is 9. Okay, so when we go to write our sequence, when we go to write our general form, it's going to be a to the n equals the first term, which is 9, plus n minus 1 times that negative 3, which again, cleaning this up, is this, okay? I want to do one more thing with this. What I want to do with this also is graph this. Now I want you guys to notice, this is actually the equation of a line. This is your slope, that's your y-intercept. Arithmetic sequences are lines, but we're going to graph it slightly different. And what I mean by that, let me kind of move some stuff over here and maybe shrink it a little bit so I have some room to work. There we go. That should, whoops. That should almost work. It doesn't want to do what I'm asking it to do. Okay. So I'm going to go and graph this. And again, I'm not going to ask you guys to do a lot of graphing with these. They're not very interesting graphs. They are just lines in the end. Let's go by, actually, let's go by 2s for the y-axis. And I'm going to go by 1s on the x-axis. So we were asked to graph the first 6 terms. So let's see what we got here. Using our formula, well, the first term is actually given. It's 9. So we have the point 1, 9. The next term, I think you guys would agree, if I plug in 2 into our formula, I get negative 3 times 2, which is negative 6. Plus 12, which is positive 6. So right here. From there, if I plug in 3, I get negative 3 times 3 is negative 9 plus 12, which is 3. But notice, we talked about how this is a line. Notice the slope of our line is just down 3 over 1 every single time. So I could keep on plugging things in using the formula, or I can just recognize the next point's going to be down 3 over 1, down 3 over 1, down 3 over 1. Now, the last thing I want to point out to you, because this is a sequence, we don't connect this with a line. We don't make a line through this because you can count the terms. There's a first term, second term, third term, fourth term, fifth term. There's no term and a half, or term at 0.3, or term at pi. It's not continuous. So when we graph a sequence, it's just a bunch of points because there's a term 1, there's a term 2, there's a term 3, however many terms we have.